Good afternoon, everyone. If you are working with large language models, you may be familiar with the following situation. You spend countless hours trying to do prompt engineering, trying to get the LLM to give you the results you want, but you are getting suboptimal results. Or you may be getting good results, but when it's time to move from a prototype to production, you see that the latency is higher than the one you want, or the cost is higher than the target cost. This is where fine-tuning comes into the picture. Fine-tuning is not just a technical exercise, it's your path to creating AI applications that understand your industry, understand your business, and your path to optimizing for cost. My name is Anastasia Dzeveleka, and I'm a Senior GenAI/ML Specialist Solutions Architect for AWS. I'm joined today by my colleague Aris, who is also a Senior GenAI Specialist Solutions Architect for AWS, and our esteemed guest, Vitalis Asanti, who is from Meta, and he's joining us on stage today. So in this session, we are going to explore how you can turn models, foundation models like the Meta Llama models, from general tools to specialized assets that can really help you impact your bottom line. So here's our agenda for this session. We are going to start with the fine-tuning model customization lifecycle. We are going to discuss the common use cases for which you should consider fine-tuning. And then we are going to dive deeper into the bedrock offerings for fine-tuning and overall model customization. After that, we are going to explore how to fine-tune Llama models on AWS, and we will close with a demonstration. So, all of these foundation models are pre-trained on large datasets containing trillions of tokens. This is how they acquire the baseline knowledge and capabilities and intelligence. With fine-tuning, you can actually increase the intelligence for your use case of these models using your own data. So you can train them on additional capabilities to perform additional tasks for your use case. Now, compared to prompt engineering, which works with the model's existing knowledge, fine-tuning allows you to with fine-tuning, you train the model further based on your own data. And I wanted to clarify here that when we will be talking about fine-tuning in the next couple of slides, we are talking about supervised fine-tuning. And that is when you have labeled examples, prompts, and responses. So with supervised fine-tuning, you can use hundreds of examples or even thousands, so it's a much smaller data set than the original data set that we use for pre-training to increase the model performance for your use case. So let's have a look at how the life cycle of fine-tuning looks like. First, you need to have a well-defined problem. For example, you may want to generate summaries for legal documents, and you want these summaries to follow a specific tone, or you want these summaries to use specific terminology. This is the use case. The next step is the most critical one, the data preparation. Now, we have worked with customers in research organizations, in enterprises, and we've heard the same feedback again and again. Data preparation, the quality of your data is the most critical and important step in this fine-tuning lifecycle. If the quality of the data is good, then higher chances you have to have a model that performs well for your use case. This data preparation usually involves things like cleansing the data, removing duplicates, and formatting the prompt and response pairs to the format that the model that you want to fine-tune expects. Once you are done with this data preparation and you have the data set ready for fine-tuning, the next step is to run a fine-tuning or a model customization job, as we call it. Here's where you train the model. You may be tweaking some parameters that impact the performance of the model. These are called hyperparameters. And monitor how your training goes, how effective it is, and iterate until you have the performance you want. Now, this is again an iterative process, and when you're done with a training round, you can deploy your models and use it. For example, on AWS, you have different services that you can use to fine-tune a model. If you prefer the self-managed approach, you can use services like EC2 or EKS. If you prefer the more managed approach, you can use services like SageMaker AI and Amazon Bedrock. And if you fine-tune, for example, a model using Amazon Bedrock, you can deploy it to an endpoint API using provision throughput. Now, many of you probably have used prompt engineering, where you are using prompt engineering techniques to be able to modify, to guide the model outputs towards the results you want. I expect that a lot of you may have also used retrieval augmented generation, or RAG, where you enhance the input to a model with additional data from the company's, organization's internal data sources to improve the results. So a common question we get is, when should I use fine-tuning and when should I use RAG or prompt engineering? So we have worked with a number of customers globally, and what we did here is that we have created this chart for you with some common problems, and we have looked at how prompt engineering and RAG compare to fine-tuning and when you should consider fine-tuning. The first problem that we see here on the screen is about making the model follow a specific output. To give you an example, let's say you're building a chatbot for customer service, and you want to make sure that the responses of the chatbot follow a specific tone, or you may want to make sure that the LLM generates a JSON that follows a specific format to be consumed by downstream applications. In this case, prompt engineering and RAG can work well, but fine-tuning does particularly well, especially for tasks that the model already is familiar with. Another example is when you teach the model a new skill. For example, intent classification, or summarizing proprietary documents, or calling APIs. Fine-tuning can be a very good solution for this type of use cases. On the other hand, if you are teaching the model a new skill, and you expect it to learn more skills, then fine-tuning is probably not your best option here. To give you an example, let's go back to what we discussed earlier. You want to fine-tune a model to generate summaries based on for legal documents. Small-scale fine-tuning will give you good results, but if you want to generalize and expect that with fine-tuning the model will learn to write better legal documents, then it's probably not going to work for you. And finally, if you want to, if you're working on a use case that you expect the model to learn, and you want the model to learn more new terminology or new things about music, then again, supervised fine-tuning with few hundreds of examples is probably not your best bet. Maybe with other capabilities like continued retraining, you may get even better results. And the reality is that there is no really a good, like a straightforward answer for when it's good to fine-tune, a good idea to fine-tune. It does require some experimentation and testing. However, based on our experience, there are three key considerations to keep in mind before you invest in fine-tuning. The first one is the model already familiar with the task? For example, does the model know already how to do intent classification? Does the model know already about video games mechanics? If it already knows about how to perform a task, fine-tuning it on your own data will give you most likely very good performance results. Second consideration, how does it perform if you do few-shot prompting? So in prompt engineering, there is this concept of few-shot prompting, where you provide the model with some examples of prompt and responses. So if that works for you, if you provide 3 to 5 examples and you see that the model performance improves, you have a very high chance that supervised fine-tuning will also work for you. Because if the model performance improves with 3 to 5 examples, imagine how well it would perform if you provided hundreds or thousands of examples. And the last one is about token economics. So depending on the service you use and how you use the models for inference, you may be paying per tokens. For example, in Bedrock, if you use on-demand inference, you are charged based on the input and output tokens. In production, if you have very long prompts, very lengthy prompts with lots of examples, you may consider fine-tuning because although there is this initial training cost during the fine-tuning, later on it may give you better return on investment because it can help you shorten these prompts. Okay, so we talked about what is fine-tuning and we talked about the fine-tuning life cycle. Let's now look at how Amazon Bedrock can help you with fine-tuning and overall with customizing foundation models for your use case. The first capability of Amazon Bedrock is Amazon Bedrock fine-tuning. So this is a managed service, a managed capability of Bedrock that allows you to perform supervised fine-tuning for models available on Bedrock without having to manage infrastructure. So you don't have to worry about setting up EC2 instances, setting up clusters, SSHing into the clusters, learning machine learning frameworks, none of that. Bedrock manages all of that for you. So here's how it works. You get your label data after the data preparation, you upload it to Amazon S3, and then you can start a model customization job for fine-tuning using either the AWS console or the Bedrock APIs. When you configure this job, you have the option to also define specific hyperparameters. And these are different depending on the model that you're fine-tuning. Such hyperparameters include the batch size, the epochs, the learning rate, and others. Once the fine-tuning job is done, you can actually start consuming the model in an on-demand fashion via Amazon Bedrock. Now, one thing I wanted to call out here is that all the data is encrypted, first of all, during in transit and at rest. But also, none of this data, model data, fine-tuning data, prompts, none of this is used to train models, and none of this can be accessed by the third model providers. So your data remains secure, and also if you want to connect to Amazon Bedrock, you can do so privately from your VPC using AWS Private. Another capability is Amazon Bedrock distillation. So distillation allows you to use a smaller, faster, and more cost-effective model with increased accuracy for a use case instead of a larger, more advanced model in Amazon Bedrock. So distillation allows you to transfer knowledge from the larger model, the teacher model as we call it, to a smaller model, the student model. How does it work? First, you provide prompts or invocation logs when you set up the distillation job. When you start the job, Bedrock takes care of taking these prompts or invocation logs and generating answers using the teacher model. It also uses proprietary data synthesis techniques and data augmentation techniques to augment your data set so that it's optimal for the distillation job. Once that's done, it uses these prompt response pairs it has generated to fine-tune the smaller student model for your use case. This is really powerful. We have seen that models are up to 500% faster and up to 75% cheaper if you use distillation, and the accuracy difference is less than 2%. Finally, the other capability I wanted to call out is Amazon Bedrock custom model import. With custom model import, you can fine-tune a model outside of Amazon Bedrock and bring the model, so the model weights and the configuration, to Amazon Bedrock and start using your model through Bedrock. So at the moment, distillation supports 3 formats, Llama, Mistral, and Fluently 5. And you need to use the Hugging Face safe tensor format, which is an industry standard. And once you import your model in Bedrock, you can start using it with on-demand inference. And actually, it's very easy to set up this distillation job. You can do it from the console. You can start the job, and then you can start using your models for inference, either via the console or by invoking an API. Now, the really nice thing about this is that you can take any model that adheres to this format. You may have trained the model on SageMaker AI, for example, or on EKS or somewhere else. Bring it to Bedrock, and then the model is automatically compatible with other Bedrock capabilities and tools for generative AI. For example, with agents, with guardrails, with knowledge bases. So you can use it like any other model that's available on Bedrock. Great, so we spoke about how to customize models on Amazon Bedrock. Now I will hand over to Aris, who will talk to you more about how to customize Meta's Llama models.
Great. Thank you very much, Anastasia. What a great introduction in fine-tuning itself and which tools we can use in AWS to actually get that done. And I want to pick it up right where you left it for us. I want to speak about fully managed serverless fine-tuning in Bedrock and which steps you actually need to take to successfully do that. And I want to also pick up the example Anastasia was giving us earlier. So let's imagine you're a legal tech company and you see that a lot of your employees are struggling with reading very long legal documents. And you want to provide your internal employees a tool at hand that they can use to have an easier life. And you decide to build a POC in order to do that. You build a POC, conversational chatbot where your employees can just dump their legal documents and they get summaries. You do a POC, you choose one of the large models leading in the open benchmarks like Llama 3.1 405B, a huge model. You decide to use that model, you build out the POC. It's going quite well, your employees love it, and then you decide to go to production and you're facing a couple of challenges. So number one is the chatbot just takes super long to respond. It's multiple seconds. It gets worse if the documents are getting longer and longer, but this is also the documents where it's most helpful. And then the second thing is price. As you scale this out to hundreds, 10,000s, 100,000s of employees with large documents, the tokens are counting up and you're paying the price for that. And you have the great idea to think about using a smaller model, let's say Llama 3.18b, and fine-tune it to get up to the same performance as the larger model at a lower latency and cost footprint. Great idea, and I'm going to show you exactly how you can use Amazon Bedrock to do that. And we're going to start, according to the life cycle that Anastasia has presented, with the data, obviously. We are still doing ML, which is a data-heavy business, right? The models are larger, the requirements for data stay the same, so we want to make sure that we get these high-quality data sets for fine-tuning. And once we have gathered them, since we are using a fully managed and serverless service, we also want to make sure that we are complying with the interface definition that Bedrock is requiring for that fine-tuning. And because we have seen with a lot of customers that conversational use cases are very popular and a lot of the customers had conversational data as examples from old school chatbots that were around for years from the POC or from other sources, we are providing a conversational interface here that is complying with our Converse API and the messages format that we have in there. How does it look like? Well, the document, the training data file is going to be a JSON line document, which means you're going to have a perfectly valid JSON in every line, and every line is going to be a training data record. As I said, compliant with the Converse API, so you can use those examples from previous iterations. And one JSON, one example actually looks exactly like what you're seeing on the screen. On the very top level, we are having two properties. We're having the system property that you can use for a system prompt. That's optional, but it usually makes sense to use a system prompt, so we recommend it. And then we have the messages property, which is actually the content, right? The conversation with the chatbot. It's an array because, we're in the conversational space, and that can be single turn or multi-turn. And then it's also a role-based message because we have a conversational assistant, and messages in a conversational assistant can either come from the user or from the assistant. But we also recognize that, some of you might not have these conversational examples, and we've got you covered here as well. So you don't need to have conversational examples. You can also just bring good examples of your specific use case. Summarization of legal documents, for example. The format is still going to be a JSON line document with one training example per line. And now we have a bit of a simpler structure. So we have the prompt, which is going to be, the input we want to give to the model in a specific example. We're going to have the completion, which is a good model answer in our training data set. In our specific case, the prompt would be, for example, an instruction prompt together with a very long legal document, and the completion, a precise and concise summary here. All right, now that we have sorted out the data, we are moving over to the training, and we have already heard that one of the knobs we can turn to get the training, the fine-tuning really well is actually the hyperparameters. And luckily for us, Bedrock is offering us that fully managed and serverless option here. That means that we are already taking care and optimizing a lot of those hyperparameters under the hood for you. But we also recognize that it's going to be your specific use case, with your specific data set, with the model you have chosen, with the prompts you have chosen, right? So there is some variation, and this is why we decided that it makes sense to expose a couple of those hyperparameters as knobs you can turn to optimize to your specific use case. And for the Llama model, these are the following two. So we have the epochs. The epochs is basically the number of iterations through the entire training data set in a training process, or in other words, how many times does the model see every single training example during the training. Default value here is 5, and you can choose between a range of 1 and 10 integer numbers. And then the learning rate, which is actually a discounting factor. It's the rate at which the model parameters are updated after every batch. In the backwards propagation, this is a floating point number. Default value 0.0001, and we also have a range from 0.1 till 0.5 times the 0 and then the 5 here. Cool, now that we know which knobs we can turn on, the next obvious question is, which hyperparameters do I choose, right? So how do I optimize for my specific use case? And as Anastasia already said, there is not that easy answer. You will need to go through a couple of iterations. You will need to do experimentation, as we did it already for years in traditional ML, and you'll probably not get it right in the first turn. So what you're going to do is you're going to try a couple of hyperparameter configurations, and then you're going to assess specific metrics that are popping up during the training. So how does the loss curve, for example, perform? Does it converge? Does it go low enough? And then you're also going to run a couple of post-training evaluations against a real-world data set, right? And you're going to see how your training is performing, and you're going to pick something that is performing best, but necessarily above the performance threshold you are requiring. So what does it mean specifically? For the learning rate, for example, you start with a value, let's say the default value. You gradually adjust it. You see how the training metrics and also the post-training evaluations go, and then you pick what's working best. A couple of things that we have seen in the last couple of years working really well is in scenarios where we have a lot of examples. Usually the learning rate becomes more important because we have a lot of examples with varying information density. So we really want to make sure that we basically have that discounting factor configured ideally. On the other hand, if you don't have a lot of examples, we can turn the knob on the epochs in order to make sure that we have enough examples that the model is seeing in total. Cool, so then we run the training, and the next question is obviously what can we achieve with fine-tuning? And I want to put some emphasis on can here, please take that directionally. We have done a couple of experiments, but again, if you do it, and I encourage you to do it, to try it out, but if you do it, it's going to be your use case, it's going to be your data set, the model you choose, and so on and so forth, right? So it's definitely going to be not going to be exactly the same. So what did we do? We once again picked up the example of summarization. We downloaded a huge data set for summarization from Hugging Face, roughly 100,000 examples, did a 9-to-1 train test data split, and fine-tuned Llama 3.18b with it, right? And then we ran an evaluation comparing it against the base model, so fine-tuned model against base model, but then also against the bit larger sister of the 8b model, the 3.370b model, which is roughly 9 to 10 times larger. And what we found was quite impressive. Against the base model, we could see a performance uplift of 45% in Rouge of One score, a popular evaluation metric for summarizations. Pretty impressive. And even against the larger model, it was 40%. So in our fictitious use case before the quality bar, we definitely met here. And then another thing that we saw on the way was actually that the models were operating in this specific task at reduced token output consumption. We were just simply getting more concise answers, roughly 77% less tokens on average against the base model, which is great on 3 angles. So if you think about it, it's a great user experience, because if you want to have a summary of a long document, you would probably appreciate it being concise and short instead of verbose. Second thing is latency. The models are generating one token after the other, and it is just logical that if you generate less tokens, it takes less time till the complete summary is generated. The exact term for that is time to last token latency metric is lower. And then third, again, we are generating less tokens, which comes with less computations, less floating point operations, which means no matter how you're going to deploy these models, how you're going to consume these models, it's going to be cheaper. All right, so you saw it's not really difficult to do that. It's super easy with Bedrock. I would encourage you to do it. And with that, I want to hand over to Vitaly from Meta, who's going to tell you how they are actually using fine-tuned Llama models in their day-to-day job and how they are basically leveraging AWS services to do so.
Thank you, Aris. Hello, everyone. My name is Vitaly. I'm leading R&D team at Meta. In practice, it means that when a new fancy technology emerges, like Gen AI and Llama, we are the team who jumps in to find business problems where this new shiny tech can be helpful and useful to the business. In practice, it means that our team operates a lot of like a startup. We have a lot of ideas to sift through, then we build prototypes, and then test those with our end users, like usually advertisers. And today I wanted to share with you 3 things. A bit of like broad stroke paint of what infrastructure allows us to move so fast to go through the ideas and iterate in our experimentation. Second, give you a few of real-life examples of where we saw Llama fine-tuning giving like really impressive results. And finally, assuming 3 of us got you excited enough about fine-tuning, leave you with a few pointers where you can start your journey in fine-tuning and play a bit with fine-tuning Llama models. Sounds like a plan? OK, starting with infrastructure. We operate like a startup. We need to move fast. And when we move from the stage of having ideas into fast prototyping, we usually start with Bedrock. Why? It's fully managed. It's simply easy to get going. We have a catalog of foundational models, including all Llama models, and all the basic tooling like knowledge bases to implement our RAG applications, and even doing some lightweight fine-tuning that Aris was talking about. And when we need like slightly more flexibility, if we want to fine-tune our models on a heavier data sets or like more diverse data sets, like images, we turn to SageMaker AI that is a bit, gives you more flexibility over the infrastructure you're running on and full control on the over fine-tuning. Like Aris was showing, in Bedrock, you get access like to 2 parameters, like epochs and learning rate for fine-tuning. In SageMaker, you get like a whole suite of hyperparameters to play with and tailor the model specifically to your use case. And like talking about like real-life use cases, Anastasia mentioned that one of the great candidates to get performance from model fine-tuning is when you need to teach model a new skill. Like around a year ago, my team was working on a project. We had to translate a large code base from our language into Python, like using Llama models. And R and Python are not exactly the same languages. Like different concepts, different libraries. We need to teach our translation model a lot of like how to handle well translating from one language to another. And that was like a great candidate for model fine-tuning. And like if you look into like broader problem space where fine-tuning may play well, we saw that scenarios like customer support training can be a good fit because, again, like you have a fixed set of problems, and when you want to teach your model a fixed set of responses to be useful to your users. Or another example, like category of problems that Anastasia referenced, when you want your responses like be forced into specific style, like content generation, like all kinds of content generation is a great candidate for that. In my case, it was like making sure that creatives for ads that we are creating have like specific styles, specific properties. What is your use case for content generation where fine-tuning can help? And there are like more and more examples that we can look at, like being mindful of time. What I wanted to touch in that context as well, like assuming you saw use case that is relevant for you on the slide, and now you're probably asking, like, you've been saying that like you have to have a high-quality data set, but what does it mean in practice? What does it mean in practice to like prepare a high-quality data set to get performance that we've been advertising, like 40% improvements in F1 scores? What we saw in practice, it boils down to like 3.5 things. First, you want to have your data set to be like well curated, like probably better word I like, more accurate. If you take customer support as an example, like if you're providing a training sample with customer problem, you'd better provide a resolution to that ticket as a training sample that actually solves the user problem. Or if you are in the same bucket, if your company has a specific tone of voice that you want to follow when talking to customers, being a bit more playful or a bit more strict and to the point, that's what accuracy of the samples mean here. Second, you want to have your data set to be diverse. Getting back to our customer service support, you want to have as many cases of problems be covered as possible. Like, if something is not in the data set, probably model is not going to pick it up. And like what I've been referencing as a like 3.5, you probably want to get a data set that either specific to your industry. Like if you're working in customer support, it can be like logs of like generic scenarios, how to handle support well. And that's you probably can acquire like in different ways. But what is even more valuable, if you have logs of your own like manually supported clients, like the data set that is specific to your problem, specific to your business domain, that would give you the best results. All right. What I'm like personally excited about Llama, it's open source. And besides publishing our models as open source, Llama team also publishes a whole suite of the examples along the model to get you going. You can find examples of how to build RAG agents, how to build like RAGs, how to build agents, and among whole suite of examples, you can also find examples how to get you started with fine-tuning. You can either just Google Llama cookbook recipes on GitHub or find the slides that we'll be publishing later to check those links. We have notebooks to get you started in a couple of hours to start playing with fine-tuning. And we are providing also a couple of parameters that we believe are a good starting point. But as Aris mentioned, it's a bit of an art and experimentation exercise. So go and play and have some fun with model fine-tuning. And where I'm going to leave you with before handing over back to Aris for some demos that we prepared for you, to give you like a visual example of what fine-tuning means in terms of responses. Like on the left, you can see like our tiniest Llama 8B model responses without any fine-tuning. When we give generic math problems, it's like not only very verbose, but not particularly accurate, like coming up with some random responses. But after a series of fine-tuning, you can see that the results are getting like sharp, to the point, and actually solving the problems that we put in front of it. All right? Thank you for coming to our session. And with this, I'll hand it over back to Aris to show you demos of that we prepared for you. Thank you.
Thank you, Vitaly. And now it's demo time. We actually want to look into how that really looks like in practice. And what we want to highlight today is a feature I really like and a lot of the customers I'm working with are loving. It's custom model import. Anastasia has introduced you to it. It's a feature that allows you, if you're following specific model architectures, the good news is Llama is one of those. You can import a model that you fine-tune anywhere else, no matter where, into Amazon Bedrock, and it's a first-class citizen in Bedrock. So this is what I want to show you, and then, you know, obviously we need to fine-tune the model somewhere, and we've seen Bedrock fully managed fine-tuning. Now we're also going to look into the SageMaker bits and pieces, so you have also seen, you know, that option. Now, we're going to use today a fully visual flow. We're going to use SageMaker Jumpstart, which is a UI-guided you know, version to fine-tune. And then we're going to use the console to import those models into Bedrock and to actually invoke them. This is because we have basically a huge audience here, and I want also the people in the last row to see what we are doing. That's not always easy if you are using code. But be sure we are API first, so you can use Bodo 3 or any other SDK or even directly our APIs to also do that programmatically, end-to-end, embedded in a pipeline or in a notebook or anywhere else. Okay, so let's get started. We go to SageMaker AI and pick the Jumpstart option in the left part of the menu. We get prompted to the model provider cards, pick obviously Meta, search for the model of our choice. We stay with 3.18b. We search for it. It filters amongst all models that are available here. We pick the instruct version of that model. We get prompted to the model card. We see there is a bit of information about the models. And then as we scroll up again, we see different options. We can deploy the models. We can quantize them. We can evaluate them. And we can fine-tune them. That's the train button. We are choosing that. And we get prompted to the UI-guided flow. We are entering a training data set. We have an example data set, but you want to do it with your own data set that is going to be residing in S3. Further down, you are seeing the hyperparameters I was talking about. This is not two of them. You will find epochs and learning rate there as well, but there is many more that you have control of here. And feel free to play around. We're going to stay with the default for today. Further down, you can pick even the infrastructure you want to use. We stay with default G5 12x large, but there is other choices. And then there is a couple of more configurations, security, like encryption or VPCs. You can select the output location of the model weights after the training. You can change the training job name even. and then you kick off the training job. And after accepting Meta's licensing terms, the job kicks off. And you are getting prompted to a screen like that while the training happens. It is executing now. You have a whole bunch of different information about the configuration you chose. And also a cool thing is that the logs are being live streamed into that overview page. And as we are scrolling through it, we can see that it really goes deep. CUDA setting up, downloading a tokenizer, tokenizing the training data. And then at some point, the model training job is kicking off. Once it has finalized, we see the status change. We can see a couple of those training metrics I was speaking about, the loss, for example. But more specifically, we want to go to the artifacts, the output artifacts, where we have the S3 location, the S3 path, to the fine-tuned model weights in safe tensors format, perfect format for importing them later on into Bedrock with the custom model import feature. We just copy that path and move over to Bedrock. Choose imported models on the left side. That's the custom model import feature. To import a model, we need to provide a model name. I've picked a creative one, Llama 3.1 8B fine-tuned is going to be the name of my model. Then we specify the path to the model weights. That's what we just copied as output artifacts. And then we click import model. It's really quick, right? Takes maybe 1 or 2 minutes to do that. And the model import is being kicked off. Now, the model importing job starts, and we can go to the jobs. We see it executing for a model of that size. Shouldn't take longer than 5 minutes in that case. And at some point, the model import is completed. We can go over to the models. We see we have a model that we imported as first-class citizen. We even have a model card like any other model in Bedrock. And with one click, we can go over to the playground to invoke the model and ask it, for example, what's the meaning of life or anything else. But obviously, we could now also go ahead and use the APIs, Bedrock's APIs, to actually include that directly into our applications. So I hope we got you excited. You saw, sometimes people think fine-tuning is really rocket science and super expensive. In fact, it's not if you do it right. Everyone can get it right. I hope it inspired you. Go ahead and try out a couple of things. We've prepared some additional resources for you, a couple of repos, both on the Meta and on the AWS side. We will also share the slides. If you miss one QR code here, session is also being recorded. You can find the QR codes as well. And with that, thank you very, very much to my co-speakers, and obviously very much to all of you for attending that session today. And don't forget to give us feedback. It's super helpful for us to improve session by session, summit by summit. And with that, there's nothing left than wishing you a great rest of the day. Enjoy the other sessions. Thank you very much.